I'd like to call up Sonia Gorgula, who's about to solve all the problems again now that all the issues have been outlaid, and now you just fix it. So thank you, Sonia.
Thank you, everyone. So I'm actually a policy person as well as Tricia. I'm hoping to pick up on a lot of the things that were mentioned during the previous talks, and the intention here is to explain how in Australia we're proposing to approach setting standards for in-water cleaning. Before I start, I just want to mention that a lot of this is still in the stage of being developed and being worked through. So the process is not yet set. The standards haven't yet been set. And you'll see at the end of my talk, there's an opportunity for anyone who'd like to be engaged in the process to get in contact with us. So I'll very briefly cover over what we actually do. And I wanted to start with how in-water cleaning policy came about in Australia, just for the context and not so much to labour on in the past, but to show you how we came to the current guidelines, which were released in 2013, revised in 2015. And then talk about what we're thinking in terms of how to take things forward and improve the uptake of environmentally acceptable in-water cleaning practices. We were really fortunate on Tuesday to include Lynn O'Connell, the Australian representative for biosecurity, in the opening addresses. And it really shows, I think, at least to our team, that biofouling is a real key issue for the department. The department has a very broad mandate, and we primarily focus on policy and program development and implementation, and we're trying to ensure the competitiveness of a range of industries, primarily agriculture. We also have a role in sustainable water resource use with a different part of the department to where we sit, I suppose. But really, biosecurity is the key way in which we meet that mandate. So ensuring that we reduce biosecurity risk is key. You would have heard from Peter Wilkinson on, I think it was Tuesday. It feels like a while ago now. But we have, our key piece of legislation is the Biosecurity Act 2015. It's relevant to mention because it has really broad powers. If you had a look in it, you won't find the word biofouling, but it is very much included within the definition of a biosecurity risk. So it's very clear that the powers that exist within the Act can be applied to the management of biofouling. So starting with a bit of the history around policy development, in 1997, the Australian and New Zealand governments, through what was called ANZAC, the Environment and Conservation Council, they developed a code of practice for anti-fouling and in-water hull cleaning and maintenance. And that really came about to address the concerns that Chris mentioned in relation to the potential for the release of non-Indigenous species and any biocides from coatings in relation to cleaning. So that's a picture there of those guidelines. They contain two key parts. So one was about the application, maintenance, disposal, removal of anti-fouling coatings. The other part around in-water cleaning and maintenance practices. The point I just wanted to make about these guidelines is that there are a number of limitations, and that's where they led to a review and to the current set of guidelines. The way in which vessels were described meant they only applied to a subset of commercial vessels. For example, fishing vessels were excluded just by definition, perhaps not by intent. These guidelines prohibited in-water cleaning without a permit, and I suppose that could be one of the key reasons why there was not a lot of in-water cleaning in Australia up until quite recent times. And also these guidelines did accept the use of TBT-based coatings on vessels that were less than 25 metres in length. So clearly as the awareness grew of the potential or actually known impacts of TBT type-based coatings and other coatings that contain those similar types of, those similar mechanisms for preventing fouling, and the international concern grew, there was more, I suppose, there was really a need to understand whether there are other biocides being used that could have potential impacts on non-target marine species just by physically being on the vessel's hull. And so really briefly, in 2001, we saw the AFS Convention come into effect, but enter into a force in 2008. In 2007, Australia ratified the AFS Convention. And actually, I meant to say that if anyone has questions, I'm really happy for this to be interactive, because I know we always tend to miss out on the panel time at the end. So please put your hand up if you want to contribute. But obviously, what I mentioned earlier, those 1999 guidelines were clearly at variance with the AFS Convention. So fairly logically, we undertook the work to then try to work out what could be within a new set of anti-fouling and in-water cleaning guidelines. The first thing that we did in 2010, we wanted to look at the technologies that were available. So there was some work done to review what had happened in terms of the anti-fouling coating space and how they had progressed since a decade since the original guidelines were in place. We also, because those original guidelines prohibited in-water cleaning without a permit, there was a need to look at how could we look at the risk of in-water cleaning, and were there situations under which perhaps the risk could be acceptably managed. So within this study, and this is available online, there are a number of scenarios that were looked at, and it resulted in a ranking of potential risk of that operation. That then led to, in 2011, we convened a group of diverse stakeholders, and Ashley Coots, who's in the room, and Olive Fleurl, I think some of his colleagues are here, they really helped facilitate that process through the groups that they worked for at that time. And what that led to was the publishing of the 2013 Anti-Fouling and In-Water Cleaning Guidelines. They have a similar structure to the previous one, so you'll see the two parts within them. And in terms of decision-making and how they were intended to support decision-making, they contain this decision support tool. And although I acknowledge it's probably not that easy to read all of this text, the main considerations are around the type and the age of the coating. Then the biofouling types, not just the level, but also the origin is important. And considering all of those, then it proposed what conditions should be met in order for in-water cleaning for the practice or on a specific scenario to go ahead. Okay. In relation to biosecurity risk, these guidelines in the decision support tool suggested capture and filtering, capture under some circumstances, but under those circumstances that the water would be filtered down to 50 microns. And this was based on the research that was available at the time. I believe Dan is probably still in the room, Dan McCleary, he and another author were doing some work on recreational boats in New Zealand and trying to set in-water cleaning guidelines back then, so 20 odd years ago. So this has been going on for some time. But out of that process, they looked at what the viable propagule sizes were. And so theoretically, through an in-water cleaning operation, if you wanted to manage particular taxa, then what level would you require the water to be filtered down to? But those guidelines, we reviewed them a few years ago, and it's really been prompted by a lot of different drivers. The 2013, I'll call them 15, so the 2015 guidelines, although their intent was to facilitate appropriate decision-making around in-water cleaning, there was really variable uptake, and in many cases, as far as I'm aware, in-water cleaning activities didn't progress in a huge way in Australia, if you put it mildly. And so really where we are now is that you heard from Peter earlier this week, we're proposing a policy for how we want to regulate, how we want to apply our regulations to biofouling risk. So with that, we need to provide options for in-water cleaning or treatment of biofouling. So we're really well aware of the need to provide proactive solutions. We acknowledge there's quite a lot of complexities in the approval processes, and I'm going to use a Queensland case study. The Queensland representatives are here as well if you want to talk to them more. I'm going to use that to illustrate the number of different steps that could be involved in an approval process. And with I suppose not just in Australia that we're looking to implement a particular biofouling policy, but as you're aware, the CRMS is in effect in New Zealand, California have requirements. Likely there will be more requirements coming. So with that, requests are also increasing to in-water clean. And often, logically, if a vessel was coming via Australia to New Zealand, then they might ask to clean in Australia. And acknowledging also that the technologies are really advancing, and as a regulator, it becomes more important for us to understand those advancements, but particularly to see independent testing of some of the efficacy of those systems. So here I want to outline one way in which this issue could be tackled and how we might develop a standard in Australia. And I have my director sitting right here. Hopefully he agrees. So we have workshopped this. So clearly our agency, our mandate is biosecurity and minimisation of biosecurity risk. So the first phase could logically be to work out where is it appropriate to draw that line, and if we were going to require filtration to a certain level, then what would that be and why? And you heard earlier from Chris, there's different ways of skinning a cat, I suppose. Different ways of looking at this, if you're not familiar with that, with what I meant there. So if you're just talking about what the biosecurity standard could be, that could be applicable to scenarios where there's a proposal to clean a non-biocidal coating or of microfouling, let's say. The second part of the issue, really, the biggest part is the contaminant risk. And so hopefully through the Queensland case study, I can start to show you some of the decision makers that are involved there. And that's a really necessary part of the issues that we need to consider in parallel, but perhaps possibly in a parallel but separate process could be how it goes. Okay. So primarily we would intend to set and develop a standard that is achievable, or that can be reasonably achieved in a reasonable time frame. So if the technologies are almost there, then that could also be considered to be achievable. Science is really important, and when I put up the definition of biosecurity risk, because our objective is to try to reduce the likelihood of the entry, establishment and spread of pests and diseases and their impacts. In all of our policy development, we look to international standards that already exist. So where we can be consistent with the IMO guidelines, that's a really important consideration. And that may mean focusing on a minimisation of unwanted macrofouling risk. And as I mentioned earlier, a standard that considers the best available technology, the future advancements that are already being trialled or are not far away from becoming operationalised. And finally, a standard that can be periodically reviewed. And rather than setting fixed timelines for that, perhaps facilitating a process where that can be more constant. So, and I've put this up because we were looking at our legislation to determine, well, how could we set up, would we set up agreements with the providers or the person who's using the system? That's yet to be determined, but ideally we want to have some way of having an agreement with whoever is operating the system where we can monitor and mitigate any risks that may arise, and that they can, through an auditing process, satisfy us that their system is doing what they say or they believe it can do. And importantly within that, obviously in-water cleaning is unlikely to be approved in all parts of Australia because there are sensitive areas that we are trying to protect and that require different levels of protection. So it's possible that some areas may be excluded, but then we may set up an agreement about where the cleaning could feasibly take place. And I realise that I'm probably putting a lot of information out there, but this is likely to come together really quickly. So the intention is to provide it all to you, give you our email address, and then so that when things come out for consultation, you can really be on the front foot and to provide your input, hopefully quite quickly. So now I wanted to cover that question of where do we set the in-water cleaning standard? And I am using the term cleaning. I realise that can mean many things. In this sense, I'm talking more about the management of macrofouling risk, but acknowledging that there may be other technologies that would maybe render the biofouling to be non-viable, but not necessarily remove it. So keeping a broad open mind for now, if you would. If we're firstly thinking about biosecurity, my colleague Tim and I have been trying to look at this in more detail, and Tim will be here tomorrow talking about some of the work we're doing in pathogens. So please come along to his talk. So what we did was we pulled out some of the results of the work that I mentioned that Dan did. And so these are some of the size classes of the major marine taxa. Where the orange line is, in the middle, so that's at the 50 micron filter level. So that's where the current 2015 Australian and New Zealand guidelines sit or have made a recommendation that the water should be filtered to. In looking at some other literature and in talking with Eugene, who is a really helpful actually, that's a good segue. So you'll notice that here at the conference, there's Eugene, there's Tricia, there's Tracy. They all have quite distinct roles, but they all work together within the New Zealand government. Often in our team, we cover off on all of those things by the same people. So we work very closely with New Zealand for that reason, because they've done some really good science. And so borrowing from some of Eugene's research and some of his analysis, you see that there are other, anyway, below the orange line, there's other major marine taxa that perhaps the information wasn't looked at or wasn't available when we considered the information back in the early, or around the 2010. There's also other things that have happened since then. Obviously, awareness of potential risks around chemical contamination have increased. And so in the state of California, in San Francisco Bay, there have been some tests of systems that filter through many stages of filtration and then use organoclay to help remove some of the dissolved metals out of the effluent. And this is to show you in theory what that looks like, really just to illustrate that, I suppose as a regulator and in thinking about standards, we do acknowledge that the practical considerations and possibly constraints that could be present. Noting though that through this test, they were able to show that if they just filtered the water, there was still a lot of copper and zinc remaining within the water effluent. And then once they ran it through organoclay filtration or that organoclay process, only then were they able to remove the remaining 80% of the dissolved copper and 25% of dissolved zinc. And that's really relevant because before they ran it through the organoclay part, the levels of copper and zinc were sort of off the charts and that water would not have been allowed back into the water column in San Fran. So to touch on my point about the myriad of interests and the need to include many regulators. So this is just to give you an example of a process that occurred in Queensland, and it was just really to show you some of the decision makers who are involved. And so the first, at the top there you see the Department of Agriculture, Fisheries, Queensland, could be considered equivalent mandate to our department. So they had a role in assessing the biosecurity risk. Next, the water quality risk is assessed by a separate department. Because if there was cleaning that was going to occur next to a sensitive area, such as the Great Barrier Reef, there's a need to involve that agency. There is the Port Authority, who have a very important role in this process. Often, ultimately, the harbour master making the final decision as to whether the cleaning goes ahead or not. Generally, if he or she has to accept the risk later and consider it, for example, in dredging operations. So clearly there are many challenges that we will hopefully try to overcome as we progress the standard. Defining in-water cleaning is a fairly obvious one. Building the scientific evidence base, but we are looking at ways in which to do that we're fairly comfortable, and that will be made publicly available when it's ready. How we independently verify the technologies or facilitate that process will become very important as a regulator. And making sure that we stay up to date with the changes that might occur in technology with the guidelines. Auditing is really important. It's how we verify that what you think the systems are doing, they actually are. And it's not that we don't have trust, but we need to have a way of providing evidence back to our ultimate decision makers. And determining the locations in Australia hopefully will not be too challenging, but there's always the potential. Time constraints is an interesting one. If the clean can't be completed during their operations within one port, and whether it carries on to multi-port cleaning. As I illustrated, the decision makers and their roles is an important thing to consider and to involve those agencies really early on and all of those stakeholders. And with that, we are engaged or trying to be engaged in as many initiatives as we are aware of. We work quite closely with the New Zealand government, with our Trans-Tasman work, with our international governments, who you've already heard from throughout this week, through the IMO and the Biofouling partnerships, of which Australia is a strategic partner. We're aware that BIMCO is also looking at setting international standards, and so we're trying to stay tapped into that progress. And also the work that Mario talked to us about in terms of the testing protocols that are being looked at currently. I'm going to race through my final few slides. The second point, the other major part of our work is involved in the review of the current IMO Biofouling Guidelines. And so Australia and New Zealand co-chair an informal group in the margins of MEPC. And as part of that, we're working quite actively to provide any learnings that we have about the uptake and effectiveness of the guidelines into that review process. And finally, while the timelines are rubbery, and that means they're not yet set, we would hope that by mid next year we will be able to make available a literature review that gives you that information about the viable propagules sizes of key marine taxa, We'd also look for input from technical experts and through the development of the standard, and I'll give you our email address in a moment if you'd like to be engaged or consulted as this moves forward. And so I think reasonably you can expect to see a draft standard early next year, with engagement occurring throughout the majority of 2020, and hopefully, ideally with a final standard by the end of next year, to hopefully coincide with our biofouling policy coming into effect, should it be approved by our minister or our decision makers. There might be a two-phase approach, as I mentioned, but I'd really welcome input and your expertise. So please contact us, check out our websites, and thank you for your attention.